Let's see how many we got today. Good morning. We'll be starting up here in a little over a minute. Oh, there's the beep at the top of the hour. So give folks about 15-20 seconds to get logged in, and then we'll get started. Okay, good morning, and welcome to our webinar today on gravels and bases, one of our foundational live webinar series. My name is David Orr. I'm the director here with the New York State LTAP Center of the Cornell Upper Roads program, and hopefully you'll enjoy this. It's a little hard to do gravel virtually, but we're going to do the best we can. Hopefully you'll pick something up. There is a handout today, if you're interested. The handout is actually the same handout we use at the highway school, so it's similar information. It looks like, go find it. I got too many windows open. There it is. It looks like this. It has some of the charts and resources that I mentioned, so you want to download that. To get to that, open up the chat pod and you'll see a link. If you haven't opened the chat pod up yet, we'll resend that link out here in a couple of minutes. I may ask you to raise your hand now and then, just if there's a quick question, we'll see. And then if you want to put questions in, you got any input, other than the polls, which we're going to do via poll everywhere, you can use the Q&A, and I'll use that as a way to answer your questions as we go along today. Now, for those who are wondering, today's session is worth 1 professional development hour for continuing education credit here in New York State, but only the person who is registered can get the credit. If you want to watch as a group, you really, no, it's something the New York Education Department has asked us to do. It's individual person. It is counted as a course, okay? And so therefore, you know, it's one of those that you have to have the courses. And then if you're from another state, you'll need to check with your LTAP center there to see whether or not this meets the requirements. And again, if you can't see the chat, we'll either type that for you or we'll put it back in the chat. Okay. So today's welcome. We'll get started with a little bit of follow-up, see who's here on our webinar this morning. But we're going to be talking about the stuff that's under the surface, though a little bit on the surface if you've got unpaved roads as well. So we're using polleverywhere.com/DavidOrrPE. So that's what we're going to be doing to get started. And so first, just find out who do you work for. So let's see who you work for here. Getting people logged in here. Also check to make sure your Poll Everywhere is working. Okay. We've got quite a few folks who are ready for the weekend. It's only Tuesday, folks. We got a ways to go, and hey, we're getting rain. I know that's hard to believe, but we're getting rain, and it's nice and slow and steady, which is good for the grass. And we actually need some rain, so that's good. Okay, so about 1/3 of you work for consultants, a blend of town, county, village, and city, and a couple of state folks. So that's good. And then, of course, as I said, folks who are honest and work for the weekend. That's always good to see. Okay. Next one here. What is your job? So again, this helps me quite a bit. Are you an administrator? Are you an engineer? Are you the highway superintendent, DPW commissioner? Are you in the field crew? Elected official, supervisor, or board member? Or you can even do none of the above. So my gut instinct today was going to be a lot of engineers and highway people, and yeah, that's pretty much what I'm seeing. Okay. And if you put in none of the above, you could put your title in the Q&A. That would help me too. Just a quick summary here. So 3/4 of you are engineers. Okay, that's good. Okay. Where are you from? You can actually put a pin on the map. It's actually pretty cool. You drop a pin telling me where you're from. Okay. Let's see where we got. And somebody put in the Q&A from the last question. They're a facilities manager. Okay, that's good to know. Okay. Well, we got quite a few folks scattered around the state. That's good to see. Okay, today we don't have any swimmers in Lake Ontario. We've had that the last couple of times, and I see somebody put in there from Pennsylvania. Welcome. Thanks for joining us today. Okay. Okay, cool. Now this webinar and all the webinars that we've been doing on Tuesday through the summer and last winter are part of our foundational or why webinar, really focusing on why we do things, trying to give you some foundation that follows on with our in-person workshops or sessions we'll do at the highway school or all the materials that are on the extensive website. So we have 2 more of them for the summer. Next week, managing the fleet, the week after, snow and ice. The managing the fleet one is not PDH worthy, but the one after that is, for those who are interested in either PDHs. Now, to help also with, as we're talking about this, let's just ask a question. I've asked this before, but it's a pretty important one and helps me quite a bit in terms of who's in the room. Why do we build roads and streets? Why do we build roads and streets? You can type your answer in, poll everywhere, pollev.com/David or P. And again, to access that, you can either type it in, or we did put a link in the chat. Mobility, moving people and goods, okay. Improve the roadway, okay. Facilitate movement of people, goods, and services, okay, all good answers. Efficient and safe travel, okay. Okay. Move people and commodities. Okay, so all good answers, all the kind of things we would expect. You can really break down the why, the things you're talking about, into 3 things. You need to account for the traffic, different types of traffic that are on a roadway, cars and trucks and buses and bicycles and pedestrians. You can account for the structure to make sure it can handle the loads that are on it, and the geometry, so you can go at the speeds that are reasonable for the particular location. Slow in a local area, residential area, a little faster, all the way up to the interstate where they're going. Very good. Okay. And it does come back down to movement, but also safety. And got to keep that in mind. That's actually a picture of my mom, my grandmother, and my uncle on a porch near the end of World War II. Got to always keep in mind what our purpose is. Now, in terms of traffic and structure, we had an instructor who taught for us for many years. He liked to say, you need to build the roads to handle the loads. And that traffic can vary quite a bit. This is in Yellowstone. This could be bison that you might see that create their own issues. But roads can come in all kinds of shapes and sizes. This is a road in Siberia, in Russia. It's the main road, east-west. It's unpaved. And it's gravel. Now in the summer, it's not too bad. In the winter, it's great. It's frozen. But their spring thaw makes our spring thaw look really, really nice. They can get some really bad problems. Okay. Let's see. It says the sound quality is not great. Sounds like you're talking inside of a tin can. Let's just check and see what my sound is picking up. It's the microphone on the webcam. Well, I'm going to have to move on. If it's not, you might check your audio. I've got somebody else who said the sound is fine, so I don't know. I apologize for that. This particular material is not a good road structure. I can just tell you, everybody can tell that. But let's talk about what is a good material to build our roadway out of in terms of the road structure. When we build a roadway, we strip everything off that's organic. These days we sell that, and we build a roadway up on top of the subgrade, the native material. So there might be a sub-base layer, there might be a base layer, and there might be a surface. All of it comes back to handling the vehicle loads. You got a load down there, okay? And that load is spread out over the subgrade. And what we're really trying to do is not break the pavement down by too much deflection, okay? Back and forth, back and forth. Now, I got the little drawing here, but a video can show things sometimes even better. This is a video that was part of something done by the Minnesota LTAP Center. And it showed testing done by the Forest Service out in Nevada. And watch the two green dots, and you can actually see the pavement move under the load of the trucks. And then all pavements do this. The more they do it, the faster they break down. This particular roadway was a testing roadway and failed perfectly. It failed just the way you want it to fail, quickly. We don't want that on our road system. And so having a road look like this after only 81 passes of fully loaded trucks probably wouldn't be the best choice. So the question is, how do we avoid that? Well, we avoid that by having a really good, proper structure. Now, if you're on a state highway, most in the state highway, your structure is a layer of base gravel and usually actually asphalt base and then asphalt binder, asphalt top. Lots of asphalt, 8, 12 inches of asphalt. Okay, so in that particular case, the gravel that you put underneath needs to be good, but surprisingly not as critical as when you get to, say, a county roadway, where you've got a relatively thin layer of asphalt and a gravel base right on top of the subgrade. And the gravel has to do more of the work. You actually need better gravel there because it's doing more of the work. And you get down to a roadway that's only covered by, say, a chip seal. That gravel is really doing all the structural work. The chip seal on top is just a surfacing for dust, for traffic, and to actually help shed some water, okay? And of course, if you have an unpaved road, the gravel is doing all of the work. Now, just to help me out, I'm going to raise your hand. How many of you have gravel roads that you manage, or if you're a consultant, that you've worked on? So raise your hand. Let's see how many folks here have gravel roads. Okay, 5 out of 56. You get a second or two. Okay, so about 10% of you. Okay. We'll talk a little bit about the differences between a surface gravel and a base gravel here in a minute. Okay. But the quality of the gravel needs to be better under low volume roads, town roads, village streets, county roads, than under the state highway, surprisingly. One of those ironies of ironies. Okay. So let's go back and look at our pavement structure a little bit. Okay. We've got that subgrade that we build on top of. We've got that subbase and base, which may be bound or unbound, and then a surface. We know that most local roads tend to be just subgrade, base, and surface, okay? So what I want you to do is help me out. We're going to do a little calculation here. What I want you to do is first, in your system, and for those who are consultants, think about the roads you've helped design or build. What's the most common asphalt thickness in that local road? Okay, 4 to 6 inches, 2 to 4. Okay. In your system, what's the most common? Okay, so we got a fight between 2 to 4 and 4 to 6. 2 to 4. Okay, I'm going to write down 4 inches as sort of our median thickness. Okay, 4 inches is our asphalt. Okay. So now let's go. What's the most common gravel thickness? How thick do you put the gravel underneath the asphalt? 0 to 6, 6 to 12. Okay. Some people have 18 to 24. Okay. 6 to 12 inches is by far the most common. I'll put down 9. Okay. It's halfway in the middle of the band. Okay. And then on all these roads, what's the most common number of vehicles you see in a given day? Closest 100. Don't give me some number with an extra digit or two. What's the closest 100? Like 400. Perfect. Okay. 1,000. By the way, if you don't know, a quick way to do a quick count is count how many vehicles go by you in a minute in the morning rush when the kids are being picked up going to school. And that number times 4 divided by 1.5 tells you the count for the day. Or another way to think about it is, if you're at 1 vehicle a minute, that's 400 vehicles a day. Okay, but let's see what we've got here. Okay, so 1,500 seems to be our dominant number. Okay, from what we're getting, we got everything ranging from 300 all the way up to 1,800, but we got 1,500 as our most common. We'll use 1,500. So now what I want to do is show you the effect of the quality of the gravel. Now, we developed through the University Transportation Centers, which should have the word research in it, but it doesn't. It's a US DOT funded source, a little tool to do some pavement design inputs. And you can actually also use this instead of designing your roadway, you can actually use it to check an existing design. Now, I know what you're thinking. I can't read this at all. Well, it's okay. You can go on our website. You can look for and just search for Road PELHI, which is actually the initials of our previous director. Wondering where I came up with the bad acronym. You can try it yourself. Okay. Now, I am making some updates and modifications with the help of Lewis County. So, when you go online, you'll find some other sources. Give me a couple of days to get that updated. It should work fine for most work, but it seems to have a problem with total reconstruction. We're getting that fixed. But the concept behind this is you check the existing pavement, you run the design, and then you can always tweak it a little bit. Now, we set this up so that you could get the whole thing done in the time it would take to do a cup of coffee. But what we're going to do now is just, we're not going to need a whole cup of coffee because I'm not going to do the whole thing. I'm going to pull the tool up. Okay. I'm going to input the numbers you gave me. Okay. So we're going to have hot mix asphalt of 4 inches. We're going to have gravel of 9 inches. Okay. And I'm going to actually zoom this a little bit. Okay. And I can choose the type of gravel. Do I have crushed gravel? Do I have a dirty unbound base? Do I have a stabilized base or uncrushed gravel that's clean, but it tends to not be as strong as if it were really clean, okay, and crushed? I'm going to start with assuming we get ourselves a nice crushed gravel, okay? Silty soil is the most common in New York State, so we'll leave that alone. I'll say the drainage quality is fair. Turns out I don't really need to know the age of the current pavement when I'm doing the testing, because in here I've got a little trick that when I run the numbers, it'll calculate the design life for me. I'm going to hit the button. It's going to ask me if I really want to run it. And while I'm letting it run in the background, and the computer screen is going to do its thing. What we want to do is talk about why gravel is so important. What makes it the most critical single product that we have when it comes to building roadways? Okay. Now, while I'm letting the thing run, raise your hand. How many of you think you have good sources of gravel? Raise your hand. How many of you have good sources of gravel? And just like before, a lot of people said yes, but a lot more are not raising their hand. We've only gotten about 10 of you so far who've raised your hand that you have good sources of gravel. Yeah. Gravel sources are getting harder and harder to find, which is why we look at stabilization and some other techniques, which we'll come back to. Okay, so we're done. Our computer did its calculation, and you can see when I come over here. I'll zoom to the selection. The design life, I get 2 numbers. One is cracking in the surface, one is rutting in the subgrade. I take the lower number, and you can see that with good quality gravel and 4 inches of asphalt and a relatively low amount of traffic, I'm not in too bad a shape. I've got myself a pavement that's going to last for a good 50 years. Cool. Great. Okay. So let's go back up here and change this. Of course, I forgot to change the vehicles per day. I'm not going to do that now. That's my fault. We'll leave it at 600 just to illustrate the point. Okay. I'm going to change it now to a dirty unbound base that's not the best quality. Okay. And I'm going to rerun it. Everything else is the same. So remember, about 50, 48 to be precise, and we're going to let it run again, and I'm going to write that number down. Okay. And boy, it's a lot faster on my work computer than my home computer. And as you can see, it's down to 5 years. What essentially is happening is there's a lot more movement because that material is wet, it's soft, it moves more like we saw in the video. But gravel really makes a huge difference. So you can put all the asphalt you want, but if you don't have a good quality base, it's not going to last. So you can call it super pave, but super pave can't overcome poor quality gravel. Now, I see somebody in the Q&A has put in recycled concrete aggregate is more commonly used in gravel on Long Island. Yeah, it can be, but it still needs to meet the same requirements for what is good gravel. So let's talk about that recipe. Okay, what is the recipe for good gravel? Well, it's pretty simple actually. One of the best things you can do, and if we had more time, we could run and show that drainage makes a huge difference. Changing from poor to fair to good drainage, taking care of that, great thing to do, absolutely vital, okay? So drainage is part of it. And you need gravels that will drain well, which is why I'm mentioning the idea of recycled concrete aggregate can be a really pretty good gravel. But you need the correct mix of materials, okay? And we'll talk about that here in just a second. You need some testing, a pinch of testing, to know what you've got, because you don't know what you've got, you might not be buying what you think. So let's talk about that. So what is our recipe? Well, our good gravel should be clean, low fines. We don't want silt, we don't want clay. Those hurt us, and New York State is dominated by silts. And some fine sands can be problematic too, but really what we want to avoid are those silts and clays. We want it to be strong, be able to handle the traffic that's on it, okay? That's one of the reasons people like recycled concrete in some cases, or they like granites and they like crushed stone and things like that. It needs to be durable. That means it needs to be able to handle freezing and thawing and freezing and thawing and not break down. It's one of the reasons we don't really want to build a road with shale. Shale's not really a great material because after a few years, it turns into silt. And that's not really good roadway, okay? It needs to have a good gradation to it, well graded to meet whatever our needs are. Open graded if we need drainage, dense graded if we want that dense graded, but graded to the right proportions that we've got. And if at all possible, we want it to be non-plastic. The plasticity is a way to measure not only the cleanliness, but also of the fines you've got, how do they behave in the presence of water? Okay, and we'll come back to that one in a minute, because it's actually very important with the materials we have in New York State. I put in angular, now I put it last. For those of you who are putting it down underneath asphalt, if I have to choose from these 6 items and I have to give one up, I'll give up angular in a heartbeat because it's not as critical in the base of the roadway. But for those who raised your hand and said you have gravel roadways, angularity is really, really critical. Because if you try to build a roadway that's got rounded stone, it's not going to stay. You see people do that all the time. They put in rounded stone in their driveway and the rocks get moved. You want that crushed base. And so think about where you're in, what you can get, where you are. Okay, so let's go back through a few of these things. Clean. What do I mean by clean? Well, gravel is actually a mixture. I call it gravel. Some people call it bank run. Some people call it crusher run. You get all kinds of names for it. We have specs that we can use, but it's really a mixture of particles of different sizes. Gravel particles that are 3 inches down to, a little less than 1/4 of an inch. There's a technical number if you really care that you can look up in the handout that's in the chat pod. Okay. Sand, which is everything from smaller than that gravel size down to just about what the eye can see, and then fines, which are silt and clay. Okay. And for good gravel surfaces, this is a gradation we found works pretty well in New York. If you're from Pennsylvania, as one of you is, or you're from Montana, you're another state, you might see specs that are slightly different. They're going to be close. The concept is the same. You'll always want lots of good big particles, gravel, whether it's draining layers or just dense graded. You want gravel, 50 to 70%. That's doing most of the work. You need some sand to fill in the voids, which is one risk when we try to use just recycled concrete aggregate, that can lead us to trouble because it doesn't have good stability. The sand is needed to help make it stable. Okay. Now, in some cases, we can overcome that if we design it, but most of the gravels we're using, we need some sand, 25 to 40% to fill in the voids. We need some fines. No, we don't need fines at all. If you're putting the roadway under the asphalt, no fines is what you really want. But real world, you're going to get some. However, for those who raised your hand with surface, you do need some fines because that's your binder. That's what holds the road together. Now I can show you numbers, but I think it's easier to actually look. And if you see, okay, in this particular case, this is a triangular textural chart and details matter, okay? You want to be in that blue zone, which is a pretty small zone. Mostly gravel, a little bit of sand, low as fines as possible. And as you get more and more fines, the fines dominate the characteristics when it's wet, spring thaw, and it starts to get too soft. Now, if you got a gravel surface, you want some fines to bind it, but the water can evaporate, so you still get softness in the spring, but not as bad. It's a nice balancing act. But I want you to notice there's no overlap between the bases and the surface. What makes a good gravel surface doesn't make a good gravel base. And when we're done, we really want that road to look like this. This is good. Nice, simple country road. Great. But if you've got too many fines and you cover that over, because you had a gold gravel road that was in good shape and you decided you're going to cover it with a chip seal or a thin layer of cold mix or even hot mix, water that used to evaporate out, instead of doing that, is going to build up underneath your roadway and boom, you're going to get this. This is a roadway that had been gravel for many years, was in great shape, but now it's actually pothole city because the water couldn't get out, it blew it apart. Okay. So in this particular case, this gravel roadway should not have been turned into a paved roadway without first cleaning up the gravel, reducing the fines content in one way or another. And we'll talk about some ways to do that before the end of our hour together. Okay. Another problem with fines is heaving. Okay. Now, I don't think they purposely put this dip in. I suspect when they put that culvert in, that it was straight line. But what happens in the winter, if you backfill your culvert with good clean material, the road heaves up around it and you get these dips. And if you've got a road that every year you find the culverts the hard way in the winter, check your fines. I bet you're probably getting closer to this hashed zone. Your fines content is getting a little bit too high. It's got to be under 8% or the fines can actually create frost heaving. A lot lower percentage than most people think. Okay. So you really want to be careful with your fines, and the kind of fines matter as well. And we'll talk about that also here in just a couple of minutes. So let me ask you this. How often should we be testing our gravel? Never. Once a year, as things change, every time we do a new job, or let's just buy state approved material only, and then no problem, right? So let's see what everybody says. Okay, everybody says, and I agree. Okay, everybody says we should do it on each job. Okay. Some people say never. Okay. So let's just come down here. And I'm going to go in here. This is pretty cool. I'm going to go over here into responses. I'm going to clear the responses. Now I want you to answer the question a different way. What do you see people actually do? What is the actual gravel testing frequency we see people actually do? Yeah, now we're seeing. This is what we see. Very few people test, less than half. And the ones who do test, they test once a year, maybe as things change. Yeah, there are still some who do each job in buying state approved materials. Okay. I understand budgets. Trust me, I'm a big fan of budgets. I've been spending way too much time looking at them lately. But we need to do some testing. Okay. How much? I would argue that if you get good at it, you can do hand test once a year with a fancy laboratory stuff, which is only a few $100s, and then check to see when things change and change it. But if you got a really big job, do it every single job. Okay. You could do state approved materials, but we'll talk about a risk that you take if you do that in terms of what you're testing against. Okay. But a test is cheap insurance. There's a company that makes big testing machines that I don't think they're in business anymore. They had a great motto. They tested concrete, and the motto was, one test is worth 1,000 expert opinions. Okay. So take a test. Even if you never test it, take a bucket. Get a sample from each pile, put it into a bucket and hold it, label it, put a label on the top, put a label in the bucket, and walk away. Even if you never test it, you've got yourself something you can go back and test later on. And then see, hey, this road failed prematurely. Maybe it's the gravel. But if you didn't take it, now you don't know. Did it get contaminated? Was it something wrong with it? So take a bucket. It's easy to do. Okay. And then what tests should we be doing? Again, at least annually on our pile or a gravel pit. We should be doing a sieve test, okay, where we check to see how many fines are in there and what's the gradation, okay. We should be testing for soundness, durability. We should be doing some plastic tests, and I'm going to give you an alternative to the plastic index test everybody's familiar with called the sand equivalent, okay. Now, the sieve test we all understand, but let's talk about a couple of the others that you may not be familiar with or you've forgotten about from your class back in college, and for those who were consultants. Soundness test is really just to see how does it handle freezing and thawing. And we could use water. We can actually there is a test to take the material, put it in water, freeze it so the crystals of ice form and it breaks the shale or the rock apart, and we can check for soundness. Okay, that's what we're really doing. We're checking to see can it handle freezing and thawing. Well, it turns out that's actually a pretty expensive test because it takes more energy to create ice crystals. And it actually takes a little bit longer to run that test as well. So the alternative is to actually use something that most people think about using for their heat, Epsom salts. Okay, you take a saturated solution of Epsom salt, you drop your rocks into it, you pull it out, you heat it up a little bit, and then you can do the cycle pretty quick, 4 to 10, depending upon the testing that you're doing. And it creates little crystals. They're not exactly the same as ice, but you can take a measure of how sound your rock is, and there are standards for that, okay? If it breaks down too much, you've got a problem. Here in New York State, the materials that have got the most problem, shales that you see all over the Finger Lakes, in the middle of the Finger Lakes, sandstones and conglomerates that you'll see throughout the Catskills, and then there are obviously isolated pockets here and there of materials that just don't hold up as well. So you definitely want to check for soundness. It's a test we very rarely do, but probably, again, should be doing once a year, especially if you get into a new vein of gravel. Check it out, because it can change pretty dramatically. We want things to be non-plastic. And when we were all in school, we all did this little testing. We had the little cup. You spin the cup pretty quickly, actually, every 2 seconds. It's, every second it should be 2 drops. It's pretty quick. And you get this little groove and you figure out how plastic it is. And you make little snakes, like the old Far Side cartoon, you're making snakes. And if the snake breaks apart the right thickness, you've got yourself a plastic material, and there's the limit. And we could get into going crazy on what this means. But essentially what we're looking at is we want the material to be non-plastic. We don't want to have a plastic regime. We want it to really essentially drain water out. And that's a measure of how it drains the water out and how it behaves under loads. Okay, we really want that. Not always possible, but luckily here in New York State, most of our materials aren't plastic with this particular test, or they're very low. The problem with that is I can get 3 or 4 different operators making that snake, and I can get very different numbers. Okay, so an alternative that we actually think is a better one for most of the road materials is something called the sand equivalent. Okay, and it is the sand equivalent, not the sand equivalence. I know everybody wants to go and make it sand equivalence because it actually, syntax-wise, is better. But the reality is, that's the name. And the idea behind this comes back to that old mason jar trick. Okay, you take your gravel sample, you put it in the mason jar about halfway up, fill it with water about 3/4 of the way up, and shake the mason jar back and forth. Put it on a shelf, and then come back the next morning, and you got a big layer of gravel, a thin layer of sand, and then all the fines on the surface. This is actually a scientific version of that test. We take the gravel particles out, and then we put it into a special solution that causes it to settle rather than overnight very, very quickly. Okay? So by shaking it, we do the exact same thing. We shake it a certain number of times with a mechanical device or by hand. Okay? We then let it settle for a fixed amount of time. 20 minutes is the actual test time. And we measure the total height of the column. And then we'll put a weight on it. And the portion that will support weight, okay, that's the sand portion. That's the part that gives us strength. What's cool about this is that the finer the material, the more clay-like the material, the higher that column gets. So if you got a really bad clay, a kaolinite, a montmorillonite, one of these fancy clays that's really bad, it has more volume. So it actually stays up higher. But silts will do that too. They'll stay in suspension and not drop down to the bottom. So you get things that are clay-like. In other words, they're soft when they're wet. And what you do is you take the ratio between the total height of the column and the part that supports weight, and that's your sand equivalent. Okay? And that's pretty simple. The sand reading over the clay reading is just a ratio. Okay? A perfectly high, just sand or gravel sized material that's got some sand in it, theoretically it could be up 100. Real world's never quite 100 because that's the real world. Something that had no sand in it at all clay, could theoretically be 0. And generally there's enough particles when you put the weight on it that it doesn't go all the way to the bottom. It's 3 or 4 really low. But what's cool about it is it's actually more sensitive for the gravels that we use in our roadways. And so when you're doing your base selection, you can use this as an alternative. Rather than looking at plasticity, look at the sand equivalent number. Because if you're looking at the base, say you've got a county road and you want to put a base gravel down, that base has got to be really clean. It's really important to get a good quality base. 0 to 5, I can't really tell that apart. I don't know whether a 6 or a 5 is really that different. It's not that sensitive to test, but the sand equivalent numbers change pretty dramatically as you get low plasticity in the plastic index test. So it's a simple test. I can run it in the field in about 40 minutes total. If we were doing this in person, I would actually have, and I have done this a couple of times, I would have a column sitting over here and we'd be watching it live. But I tried thinking, how could I do that on the screen? And I realized it's not going to be as effective anyway, just because you don't know if I'm just cheating, pulling one cylinder out and showing you another. I'm not going to do that to you. But the sand equivalent is a pretty cool test, doesn't take long to run, and can actually be run in the field. So it's a pretty good way to look at things. Okay. Now, in terms of gravel spec, as I said earlier, you could always buy state-approved material. Great. I'm a big fan of buying state-approved material, but make sure you're asking for the right material. So how many of you, raise your hand, use item 4 gravel? Item 4 gravel. Anybody raises their hand today? Okay, too many of them have heard me before here, Jeff. Yep. Well, I'm glad to see nobody's using item 4. Item 4 is a common term we use for gravel here in New York State. It doesn't actually exist as a spec. There is a type 4 304 within the standard specifications. And yeah, I know paper copies, it's all electronic these days, but it's nice to show an old book. The gravel spec that the state uses, that's that type 304 material that you probably have used. Look at the fines content on it. Does anybody know off the top of your head, you can put in the Q&A, what the fines content of type 304 material is? If anybody can, in the Q&A, tell me what that number is. Nobody's willing to take a guess. Or they're looking it up quick. I don't know which. 5%? Good guess? I wish it was. I'd love to see 5. But remember, the state, it's paved asphalt surface, asphalt base, and then the material is a sub base. It doesn't need to be as clean. So the state actually allows, okay, we'll see if my little toy works here. The state actually allows, ooh, that's a bad color. 30%, not quite that high. That would be probably going too far the other way. But the state allows 10% fines in their type 304 material. And remember, I said 8% is the maximum, because above that, you start seeing frost susceptibility. So you might want to think about a different spec, one that does have a slightly lower fines content. And so we actually worked with the state in the state spec. It's for type A, type B, and type C for surface, base, and subbase. It's 667. It's in the materials only. Okay, and in that particular case, the amount of material matches that chart that I showed you. So the surface, the fines content is 8 to 15. The base, 0 to 5. And the subbase, 0 to 8%. Okay. So there's a spec out there. And so if you want to do state approved and using that, great. The other thing I would have you do is go learn some of those old hand tests. They don't tell you the numbers. They're not going to do much more than tell you something has changed, but they're very useful at that, because if you've got a test that you've done from a laboratory and you do these hand tests, you can see when things changed, and now you need to go do a new lab test. Now, somebody here, if somebody asked, is number 35 gravel the same? That's a Pennsylvania spec, if I'm not mistaken. I'm not positive about that. You need to look at the spec. Just look at the spec. The Pennsylvania dirt and gravel road folks have a driving surface aggregate, which has a similar fines, a little bit more fines in it, but you can look at their specs and some others with low fines. The key is low fines, low clay, low silt. Okay. Now, in terms of tests you can do with your hands, my favorite one, just take the material and put it in your hand. Just rub it in your hands and see. You got dirt on your hands? Probably got a little bit of silt. You need to check for that. Take a hammer, hit it with a hammer. I actually like to have a small piece of metal in a small 1 pound, 2 pound sledge, just drop it lightly on the stone. It should break after a few hits, of course, but it shouldn't break easily. And it shouldn't shatter into nice clean faces. That's a brittle failure. And it probably means you got shale or weak material or conglomerate. Take the big stuff out, take all the fines, and see if you can make a snake out of it. It's a field version of the plasticity test. Can be very useful. If you can make a snake, you probably need to check for that plasticity of the sand equivalent. Take the material, that same material, put it in your hand, make sure it's wet, tap your hand a few times and look for the water to come to the surface. If it does, it's probably silt, which is great from it's not clay, but it's bad because it means it's probably more frost susceptible. And then of course, you can take that same material, put it on the shelf, come back the next day, try to squeeze a small, half-inch size piece of material. If it breaks apart and goes in a big poof, it's mostly silt. If it holds together pretty strong, it's probably clay. Because remember, clay, if it stays dry, is extremely strong. And if you don't believe that, you got a porcelain coffee mug, remember, it's made of clay. The other thing is go stop and talk and look and listen to folks. Go out to the gravel pit. Go talk to folks who've used that material. You'd be surprised. I bet most of you know your good sources, and you also know the sources that have become not so good lately that you're like, I'm not sure what's going to happen here. So now you start thinking about going and getting a test. Okay, do I really want to buy that new hat? Now, I said we want to be inside that blue zone. The two tests always be running as a sieve test and the sand equivalent, though I certainly want to look at some of the other tests such as the soundness. But I've run my test, I got good materials, but let's be honest, an awful lot of materials are not in that blue zone. They're outside of it, okay? Now, if you got something that's sitting right here, come on, Pin, wake up. Oh. There we go. I got a material that's sitting right here, just outside, okay? The blue zone. It's a little bit heavy on the gravel, little bit light on the, light on the sand. These are lines we draw. Don't go crazy trying to be absolutist, especially if you're going laterally. Now, be real careful about the fines content, but the other ones, you're not perfect. You can probably blend something in and make it work. But if you get too far away from that good zone, you need to clean it up somehow. You need to get the fines content down for sure, and you may need to do something. Now, the technique that we like to use, you've already seen our friend here, FDR, full depth reclamation or just reclamation, where essentially you clean up the existing base or even some existing piles of gravel. You could do that at a gravel pit, and you clean that material up. Okay. Now, I'm not talking about going deep. Okay. I'm talking about the base, the first 8 inches or so. Okay. Oh, by the way, today's safety lesson, I think there was a few safety violations here. So we talked about earlier why we build roadways. When we build them, we got to be thinking about going home too. So let's not do this. I once went through a group and we counted something like 15 violations here that could cause the job to be shut down. So I don't want to see that in anybody's job. But here's the thing is, most roads have evolved, especially the local road system. This happens to be a road in the town of Pavilion from a book written over 100 years ago by the Department of Public Works, which was these days we call the New York State Department of Transportation. And so it's a town road. It was gravel. Most of our local roads were gravel when they started. And they were pretty good gravel roads. They found sources that held up under the loads that were on it, mostly horses. But eventually we started getting trucks and equipment going down them. So we modified things. We got a good crown. We got a good gravel surfaced roadway. Well, public demand, traffic volumes go higher. People want to pave it, which is fine. But remember, if you pave it, you've probably got a gravel that's in that hash zone. It's going to have a little bit more fines to hold it together. Now you pave it, it's going to fall apart. So before you pave it, you may want to think about cleaning it up. Or just as common, we've got an existing road that potholes every single spring. You might want to check and see what's going on underneath. I bet you're in the hash zone. You'd be amazed how often we found that when we've talked to people or we've done our own test. Okay. Now you could stabilize these materials. And how could you do that? Well, the easiest way to do it is just pulverize what's there. If you've got 4 inches of cold mix or hot mix on top of the existing gravel and you're close, just mixing the two together may get you in the blue zone where you need to be. You could mechanically stabilize it. That's a fancy word for saying you could bring in some fresh stone. Just bring in some stone. When the blend is done, you're done, walk away. Okay. That's a case where those recycled concrete aggregates can work really well because we know they have no fines, mostly. And so you blend them in, you can drop the fines content pretty quickly. You could use chemicals to stabilize, bind those fines up. Okay. That's a pretty cool technique that works pretty well. Okay. Most of the time in New York State, we tend to use salts. Okay. Calcium chloride, something like that. But remember, with the calcium, the fines content doesn't change. It just changes the frost susceptibility. So if you really need to get rid of the frost issues, you need to be thinking about bringing in cement. Now, I put in lime fly ash, mainly because I don't know who might get on our webinar. Not likely to be used here in New York State, because to make it work, you may actually have to bring in something to react against the lime. You need a little bit of reactive material, usually some clay in there, to react. Adding fines in before you add in your lime seems like a risky thing to do. But there are parts of the country where the subgrades are such that, or the subbases are such that this works really, really well, lime fly ash. There are other techniques for adding fibers these days and things like that, but let's talk about existing techniques right now, okay? And then, of course, the one that's probably the most common stabilization technique used here in New York State is bituminous, where we use emulsion or foamed asphalt, and we could do a whole webinar just on those techniques. They're pretty cool. In fact, we actually have done a stabilization webinar. But I just want you to keep in mind there's ways to stabilize your existing material. Could you combine these together? Well, of course you can. That's always something you can do when you combine things together. Here's a demo we did at our highway school almost 20 years, 20 years ago, not quite years ago. 2007, I think. I'd have to look it up. But in this particular case, we did cement stabilization because the fines content was fine for asphalt, but the sand equivalent number was not. It had the wrong kind of plasticity to it. And it wasn't really the best candidate for doing asphalt stabilization. And there's our former director smiling on the job well done. But it does remind us of something. This particular spot looks like it's in great shape. They're working on it. Everybody's walking the job site. This is a picture that was taken about, a month or two later, okay? And does anybody notice, can you see the crack right here that's running about halfway through the photograph? You see that line, that black line? That black line is not a shadow from an overhead wire, okay? Gotta make sure. That's actually a crack that formed, okay? When you do stabilization, one thing I want you to remember, don't add extra. If the lab test says add 4%, add 4% of whatever it is you're adding. Don't add extra, because if it's extra, it creates problems. If it's extra asphalt, it can create balls and actually make it soft when it's the right type of year. If it's cement, it can make it brittle, and that's what actually happened in this case. Too much cement became brittle and it got cracks, and they actually had to go in and fix the cracks and then overlay it. You really don't want to have to do that, okay? So when it comes down to base selection, remember, here's what we want. That's where we want to be at the end of the process. We want to have fines content in the ranges shown, like 0 to 5 for the base. Sand equivalent want to be good. Plasticity, we want to be good. But a lot of our materials don't meet that. So how do we convert from one to the other? Well, we don't have it. If the fines content is 0 to 10%, most of the time we can just bring in some aggregate or pulverize it, assuming you have a good sand equivalent number. Because by the time you mix those things in, you've got pretty good sand equivalents when you're done. If you've got enough fines in there to make it worthwhile, you can actually add asphalt, okay? If you don't have enough fines, don't add the asphalt. It actually makes it softer, okay? But again, you still need some plasticity to be very, very low. And the traditional has been look for plasticity under 6. But what we found is you really want to look at the sand equivalent number, because again, it's hard to tell apart 0 to 6 what the plasticity is. And if you've got no plasticity, you can actually get away with a lower sand equivalent because you don't have to worry about those clay particles getting in the way. But the sand equivalent's a better test in this particular case. You could use calcium chloride if you've got a good sand equivalent, but remember, you're still going to have the same fines when you're done. But for low volume roads, good technique, reduces the frost susceptibility, reduces the spring thaw problem. Very good technique, and works on a wide range of fines contents. And then, of course, you could always use cement. And again, I put in there just so you know the lime fly ash issue, but you do need some plasticity. It needs to be above 11, where the plasticity now becomes the more important than the sand equivalent. Okay. Now, in the Q&A, before I move on to my final points here in our Pdh Questions, what is the single most important determinant if I have 2 or 3 of these that meet the requirement? If I could choose between these stabilizers, what drives which one I would choose, assuming it meets these requirements? What? See what people put in the Q&A. What's the one big driver that should drive it? Yeah, I almost put this to poll everywhere, but I decided I'd do it in Q&A. Let's see what y'all come up with. Fines percentage, okay. But I could have, for instance, I could have something that's in the 12% range that would meet the requirements for asphalt, calcium, and cement. And let's assume I got a pretty good sand equivalent number, okay. So I've got a good sand equivalent. So I can choose between asphalt, calcium, or cement. All 3 would work. How do I decide between those 3? You all know the answer. You're all thinking about it. Plasticity indices. Plasticity, if you got a good sand equivalent, you're going to have a low plasticity. I can tell you that right now. What drives any decision we make? How do you decide between buying a Hyundai or a Ford? There we go. Cost. Time and cost. Everything I'm talking about, always got to go back and look at the cost. And so at the end of this, if you have multiple choices, look at the economics. What's going to be cheaper long-term? What's going to last longer? Generally, if you meet these criteria, you can start at the top and work your way down, with the exception of the lime fly ash in terms of general cost. But You want to have all of these tools in your toolkit because we have a lot of materials that don't meet the sand equivalent. And now you really need to be thinking about cements and other techniques. To know, you got to do a test. There's nothing else I can tell you. You got to get in the hole. You got to do a test. I'm a big fan of test pits versus just cores because you get more material. You can see it easier. Okay. And I could have shown you a modern test pit we did up in Lewis County a couple of weeks ago. Actually, I guess about a month ago now. I figured I'll show the picture when I actually had darker hair. You can see what's going on. Go do a test. One test is worth 1,000 expert opinions. Okay. So now we're going to finish with our Pdh questions. Okay. They're pretty simple. I hope you can get them right. At least if you don't get them right, it's my fault, not yours, because I didn't teach you well. Good surface gravel makes a good gravel base. True or false? Good surface gravel makes good gravel base. Oh, you're making me feel good. Okay, yeah, it's a false. Okay. If you've got a good gravel surface and you cover it over, you probably had some fines, 8 to 15%, just by default. You put a chip seal on it, you put a cold mix on it, you put a hot mix on it, the water builds up, blows it apart. If you've got existing roads that break down every spring, they're potholing, check the base. I would be stunned if you don't find a high fines content or a low sand equivalent number. Okay, one or both. And that leads to this kind of problem. Okay. So what's an alternative to the plasticity index test? You can type this one in. Now it's going to be a Wordle. So if you type in the full name, you're going to show up with words, but SE is another way to think about it. Yep. Sand equivalent. Yeah, y'all are getting pretty good. Don't know what the kidding test is, but yeah, sand equivalent. Very good. I'm a big fan of the sand equivalent test because of the fact that it seems to be more sensitive for the materials that are glacial tills, which is almost all of New York, large parts of Pennsylvania, and even in places that didn't have the glacial. If you've got silty materials, this tends to be a pretty cool test. Okay. Full depth reclamation stabilizer can be chosen from a surface analysis only. I can choose my stabilizer by just looking at the surface. Now, okay, I think you know that one, but let's be honest. Way too often we choose the solution. We look at the road and we go, oh, we're going to use asphalt. Oh, we're going to use calcium. Oh, we're going to use cement. You got to go out and you've got to do a test pit. You really need to know what's going on underneath. Nothing else, figure out what's going on in the drainage. When we did that test pit up in Lewis County, we actually found one of the two places we stopped looked like they had a thin layer of asphalt, put gravel on it, and then road on top of that. Well, there's your drainage problem. You're locking that water in, and you got a layer that's not going to move that well. So go out there and do a pit. Do the snake test. Do some testing. Okay. It's a few $100s. It's cheap insurance. Okay. Now with that, we do have 2 more Y webinars coming up after today. Next week is managing the fleet. Tim Hunt from Lewis County is actually doing that for us. Got some really cool stuff on how they managed the fleet when he was with the town of Casanova, and he's now replicating that up in Lewis County. And then the week after that, we're finishing off our summer series with snow and ice. We'll be doing our fall workshops and then starting these webinars up again after the bridge conference. We'll get the advertising out and the dates on that out pretty quick, but hope to see you all next 2 weeks and see you on the road with our workshops. Next week, we do have some safe systems workshops that are Pdh worthy over in Poughkeepsie, up near Utica, and out in Monroe County. We are holding them, but we got plenty of space. We'd love to see you. With that, I want to thank you. Hope you picked up something out of it. If you have any questions, just send us an email at clrp@cornell.edu or find us on the web at NYSLTAP-CLRP, Cornell.edu, or just search. Google's really good at finding us. Okay. Hope you had a great day. I'm going to give you back 2 minutes. And stay well, be kind. Bye-bye.